All right. We're going to go for one that's going to calculate out a little bit weird. I think I'll use this as my example for tangent lines and, of course, implicit derivation. They call it the 8 curve. It's number 45 on 172 in the book. Let me draw the curve a little bit here. There's a bit of symmetry here, but we're going to focus on one point. They ask for 2 points in the book. We're going to focus on 1 point. So we have root 3 over 4 as our x value, and root 3 over 2 is our y value. And the function, or the relationship that defines this curve, is y to the fourth equals y squared minus x squared. And so the book asks for the tangent and the normal. We'll find the normal. All right, if we find the normal, we can also find the tangent at root 3, 4 over root 3, 2. The other point they ask for is root 3, 4, 1/2, which also exists down here. There's a root 3, 4, 1/2. And I'll leave that to you working on the problem. So we need to find dy dx. So to find dy dx, we're going to differentiate this with respect to x. And then we're going to pull our, y cubed. All right, we bring the 4 down, that becomes a cubed. And we're going to bring all the dy dx's together. Equals negative 2x. And then we're going to pull out dy dx. That's the thing we want. And we'll solve for it. And so now we have a function where we can find the slope given the two parameters of the point. And so we're going to evaluate dy dx at root 3 over 4, root 3 over 2. So negative 2 times root 3 over 4 over 4 root 3 over 2 cubed minus 2 root 3 over 2. Do a little bit of cleanup here. Let's see, the 2 will cancel here, so I'm going to get negative root 3 over 2 upstairs. Downstairs, I'm going to get 4 over 8 because of this here. And then I'm going to get root 3 times 3. Right? Because if I cube this, I'm going to get it squared times 1 more, minus, and then these are going to cancel here. So I'm going to get root 3. I'm starting to like this. This doesn't look as bad as I thought it would be. So that's going to become 1/2. So I'm going to focus on the denominator right now. I'm going to try to clean up what the denominator looks like. So this is 1/2. So this is 3 root 3 over 2 minus, this is 2 root 3 over 2. We'll give it the same denominator. So upstairs I get negative root 3 over 2. And then in downstairs I'm going to get a positive root 3 over 2. And so my slope is negative 1. All of that for a negative 1. Okay, I'm going to bring it over here. So if my slope of the tangent line is negative 1, then my slope of the normal will be negative 1 over the slope of the tangent, or it's going to be positive 1. So this means that I can find my normal line. So y normal minus y1 equals the slope normal times x minus x1. So y normal minus root 3 over 2 equals 1 times x minus root 3 over 4. So y normal equals x minus root 3 over 4 plus root 3 over 2. And 2 of these for 4, right? 2 root 3 over 4. And so that's going to be plus root 3 over 4. Right? You can kind of in our head see this is 2 root 3 over 4. And that's minus 1, so plus 1. And so we have our normal line for our figure 8 curve.